and it's somewhere that ASB have visited in the past and hopefully will visit in the future. He's a professor of cosmology there. He got his BSc from the University of Addis Ababa and his MSc and PhD from the University of Cape Town. And his research is mainly in cosmology. I don't know whether we can, Professor Abebe, whether you have your slides ready to go.
Yeah, thanks for the introduction. I have my slides ready to share. Okay, so how many minutes do I have?
You can have, well, about 50 minutes plus 10 minutes for questions, something like that. Is that okay?
Okay, yeah, that's pretty much what I prepared for you.
Anyway, we're extremely pleased that you can make it this evening. We're very much looking forward to the talk and learning more about the Astronomical Society, the African Astronomical Society. Thank you.
It's a pleasure, and thanks for giving me this opportunity. Can you see my slide?
It's a bit small. Well, it isn't actually your slides. I think it's it looks like your file list.
Oh, let me again. And now?
This looks more like it. That's it. That's the one. Yeah.
It's on full screen.
That's it. Yeah.
All right. Thank you. All right, so I have titled it Building a Bright Future, AfAS and the Growth of Astronomy Across the Continent. And I'll start with this schematic of our place in the universe, which I usually start my slides with because it kind of sets the perspective.
Yeah,
so
Don, sorry to interrupt. Don's got his hand up. Is it because that doesn't fill the whole screen, Don? Is that what you're saying?
Yes, it is, Mike.
Okay.
Is it not full screen? Let me see.
It hasn't filled the full screen.
Okay, let's see what's going on. Nope. Not that way. View. Yeah, I put it on full screen mode. Is it probably no? This can't be.
Oh, that's.
This is not what I had in mind, though.
It's like it's cut. Yeah, it's like it's cut off at the top and bottom now. I don't know.
Let me try to open it with a different.
Yeah.
Okay. It makes any difference. I don't think so.
No, that's worse, really.
Yeah.
I think if you went back to how it was at the beginning, I think we probably just about read it. But...
Okay. That's bad. Okay. Yeah, I'm gonna try with this one then.
Okay.
Okay, yeah, I was saying that this is to depict our place in the universe. This is a the schematic of our galaxy, which is one of those average
Yeah.
galaxies in the universe with.
Yeah, sorry, Prof.
Yeah.
We can't see it now. Sorry. Can you try sharing again?
Yes. Is it sharing now?
Yeah, you can see it. It's still small, but okay. I think we can read it. It's just a bit smaller than it would normally
It
be.
is a bit unfortunate though. Okay.
Yeah, I think we probably have to live with that unless you can. I think we can read it and see what each slide. So I think we'll probably have to go with that if that's okay.
Okay. Yeah. That's the only thing we can do at this point,
Yeah.
I think.
Okay, let's go. Yeah.
Yeah. So this is to put our perspective in terms of place in the universe and to show that we live in part of a universe that's pretty much average, nothing particularly special about it. An average galaxy, and we have the sun somewhere in that part of the arrow where the sun is in no particular place in that galaxy, and the sun itself an average star hosting planets, one of which is the Earth, an average size planet there, and in the bigger picture of the universe, we are in a location that is pretty much indistinguishable from the rest of the universe and very small in terms of the scale of things. And in terms of our time in the existence of the universe, also we occupy a very small section of the time, the lifespan of the universe as well. So the outline of my talk, I will briefly talk about the story of our cosmic origins, cosmology, and astronomy across human civilization, what people have been saying about where we come from and what is the universe like and all that. And talk about the African side of that story, and then move to modern astronomy and why we do we study modern astronomy, why it is important, and the current states of astronomy in Africa, and goes then to the main topic of my today's talk, which is the African Astronomical Society, its vision, structures, strategies, and partnerships, and so forth. Okay, so we have always pondered about the nature of our universe, our place in it, and so forth. And one of the earliest depictions of this story of our cosmic origins is from about 3000 BCE, which is about 5,000 years from today ago. And this is the so-called turtles all the way down picture of the universe, where if someone asks us, where is the Earth? What is the Earth supported by in place in space, for example? One will tell you it's supported by these giant elephants that are supported by turtles, and each turtle is supported by other turtles all the way down. So this is one theory, myth of the creation of things from thousands of years ago. And then a bit later, we have this Middle Eastern picture of the universe, where we have a flat circular Earth enclosed in a cosmic ocean. You have the Earth, and the others, you have the underworld, and you have the firmament, and above that you have the gauge. And yeah, picture. And then in ancient Greek myth and philosophy. We have people like Anaximander who proposed this unlimited, indeterminate, and indefinite ground, and the nature ruled by natural laws. Earth not flat, but cylindrical, kind of a slight deviation from the previous versions that we just saw. And then we have people like Pythagoras who proposed that we have this place in the universe called the Uranus, and then we have the cosmos, and then above that we have the Olympus, the home of the gods. The cosmos is the movable heavens, the sky basically, and the Uranus is the earth and other sub-lunar realms, as he called them. And it's a strictly mathematical universe, and in his opinion, number rules the universe. And then comes Aristotle, which I'm sure many of you have heard of. He was one of the first scientists in the modern sense of the word, but not really in the sense that I will talk about after Galileo. He was a philosopher through and through, of course. And in his picture, we have this geocentric universe where the Earth is the center of everything. Even his theory about why things fall toward the Earth is because he thought the Earth is the center of things, and everything is going back to its natural abode. And in his theory, the Earth is stationary, the cosmos is finite in extent and infinite in time. And people like Aristarchus after that had this heliocentric universe where the sun rather than the Earth takes the central position of the universe. And he actually knew at the time that the sun was bigger than the Earth, and Earth rotates around its own axis while it orbits the sun. This was, for me, very interesting, given that at that time people did not have, sophisticated astronomical instruments to measure distances and sizes in the universe. And then, of course, we have Ptolemy with his famous geocentric picture back again. The sun, moon, and the planets, or the other planets, are on epicyclic orbits around the Earth. The Earth is at the center of things, and that lasted for more than 1,000 years, actually, until we had Copernicus in the mid-16th century with his geocentric picture of the universe, heliocentric rather, picture of the universe again. And we have seen this picture from Aristarchus before him, of course, but nowadays we think Copernicus came up with this idea as a brand new theory. So according to the Copernican picture of the universe, everything revolved around the sun and not the Earth. And so one of the clearest proof of that came when Galileo observed moons of Jupiter that were revolving around Jupiter, but not the Earth. So it was revolutionary in the sense that once and for all, this idea of the Earth being at the center of everything was disproven. But the fact that he proposed the sun was the center of the universe had to be again, refuted later using other observational and theoretical principles. We now know the sun is not the center of the universe. It is the center of the solar system, if you will, but not the universe. And then after Copernicus, but before Galileo, we had someone called Giordano Bruno who proposed that the universe is infinite in size, and there is no center and there is no circumference, but the center is everywhere. This was a very revolutionary idea at the time, so much so that the church did not take this lightly, and he was burned at the stake for his views of this world, universe. Galileo is often taken to be one of the fathers of modern science, in the sense of following the scientific method to prove things, to whatever theories are proposed, they have to be judged based on their truths, based on their observational evidence, and so forth. So he was not a man of, opinions based solely on authority of the church, of religion, of people, and so forth. That's why he had this saying that for in the sciences, the authority of thousands of opinions is not worth as much as one tiny spark of reason in an individual one. I really like this this quote of his. And he also, of course, went through lots of troubles with the Catholic Church at the time, and you might have heard of his, years of suffering at the hands of the church. And then we had Newton in the 17th century, who proposed this universal law of gravitation, and that was later improved by Einstein, as you'll see very soon. And then after that, we have someone, a philosopher, German philosopher called Immanuel Kant, who proposed that we may not be the only, well, our universe may not be just the Milky Way galaxy, but there might be many other galaxies out there. He called them island universes at the time. And that was also a revolutionary idea at the time. And then comes Einstein, who basically revolutionized the way science works, the way especially astronomy and cosmology functioned afterwards. And he's considered to be the the father of modern cosmology. And he had this generalization of Newtonian gravity by saying that there is no such thing as gravity per se, but there's a curvature of the space-time that is formed due to the presence of matter in that space-time, and matter follows that curvature. So instead of matter following fictitious force field, the form of gravitational attraction, actually following a space-time curvature. So from the 1915 onwards, we have general relativity as the foundation on which modern cosmology and astrophysics are based. Okay, so this is what we know about the universe based on Greek, Babylonian, or European conceptions of the cosmos. But African cultures had their own rich imaginative and symbolic frameworks for understanding the universe, and this is what I'm going to briefly talk about. And you'll notice that while I had several pictures online when I went through this other conception of the universe across civilizations, I could not find these ones online, so I had to generate the image using AI tools. That also says something about how much African myth and African astronomy has not been in the mainstream media, so to speak. Okay, so I've got some tables showing different cultures and different deities, key deities in that culture, and what the view of the universe look like, but I'm going to rather go through the specifics here, and then I start with this so-called Dogon cosmology. The Dogon are people of Mali that have long traditions of cosmological beliefs linked to the star series, known to them as Otolo. And according to them, they actually spoke of a companion star for series called Series B, before modern astronomy could say something about them through astronomical observation. And the universe to them was born from a god called Amere, the supreme being who created everything by unfolding spirals of matter. So before there was anything, there was Amere, and from Amere came the egg of the world, according to the. And the Zulu cosmology, we had the Zulus believing in a sky deity called Unkulunkulu, the one who came first, associated with the sky, thunder, and creation. And the world was born from roots, and life arose from a primordial river of energy. In the Sun Khoisan cosmology, we have the Milky Way as a guide. They believe, the Sun people believe that the Milky Way was created when a girl flung ashes from a fire into the sky to help hunters find their way home. So the stars are seen as footprints of ancestral beings walking across the heavens. And the night sky was Bo's map and me. And the Ashanti people of Western Africa, they believed the sky and earth were once close together, but humanity's actions pushed them apart. That's Ashanti. And the Dinka of South Sudan had Abu and Garang, the mother god and the father god, that made the humans first from clay and placed them in a universe held in balance by rain, cattle, and stars. In the Ethiopian Oromo cosmology, we have the Waka, who create the universe, the earth, and celestial bodies to govern time and life. And according to that tradition, the Waka maintains cosmic balance. Stars and lunar cycles guide time, ritual, and morality. And finally, we have the Egyptian cosmology that had this idea that the universe began in a dark, boundless ocean called Nun. From this, Atum or Ra emerged and created the first gods and all of existence. And the sky goddess Nut arched over the earth, and the sun traveled across her body each day and was reborn each morning. So that is basically to just give you an idea that astronomy in Africa was not, in the general sense, a new phenomenon, as some believe, but something that has been with us for thousands of years. And now, if we come to modern astronomy, we see that from ancient stargazing to precision cosmology, astronomy has become a model of scientific spirit driven by evidence, logic, and wonder. And modern astronomy is a branch of physics that studies the universe through observation, experimentation, and theory. Whereas the ones that we just went through in terms of the myths are mostly, human beliefs without necessarily going through a rigorous observation and reproducibility of results and independent peer reviewing and so forth. So modern astronomy relies obviously on the scientific method, which is a rigorous, repeatable process for uncovering the laws of nature. And in the scientific method, as far as astronomy is concerned, we have observations with telescopes that gather light across all wavelengths, optical, radio, X-ray, gravitational waves, and so forth. And we have hypotheses, models, astrophysical models that describe evolution of galaxies, dark matter, dark energy, and so forth. And then these models have to predict something, and these predictions need to be tested with observations. And those that pass the observations can go to the next stage of, being considered more seriously. And if some other observations come later and disprove those, then those theories are ruled out and so forth. So this kind of models are good theories. If you can falsify the predictions, they are good theories. And then through gradual refinement, these theories evolve to fit the data. For example, general relativity, models of dark energy, and so forth. Why do we care about astronomy in the first place? Well, it is really the most accessible science. All one needs to do is to just look up. We don't necessarily need to have sophisticated instruments like telescopes and the like, and other facilities to wander, to look up and study about the universe. Well, of course, if you want to be more technical, if you want to understand the deepest reaches of the universe, one has to, as we'll see soon also, have sophisticated instruments. That's why we're investing a lot in Africa, for example, the SKA and the like, right? But one can start by just looking up, and it makes it the most accessible science. It combines wonder, combines data, it combines imagination, it combines precision. And it's also a great gateway to the STEM fields, science, technology, engineering, and mathematics. Because to do astronomy, to do cosmology, you need to get a good grasp of these fields. It encourages critical thinking, innovation, and leadership. And real-world solutions applications involve things like weather forecasting for agriculture, satellite communication and navigation. Think of GPS, for example, disaster monitoring, infrastructure planning, and so forth. So astronomy is not a luxury science. It is actually practical. It has several spin-off skills that come as a result of doing astronomy and so forth. Okay, so what does the current state of astronomy in Africa look like? This is an estimate, to the 2025 estimate of, the number of professional astronomers, by that I mean PhD holding astronomers in Africa. And it's not necessarily the AfAS members that we have at the moment. I'll come back to that a bit later. But those that have PhDs and are working in Africa. Some of it may not be accurate, so I stand to be corrected, but this is based on, data I try to collect as much as possible. So yeah, you'll see that South Africa has by far the largest number of professional astronomers, and the rest of the countries in Africa has those number of astronomers in that country. And if you add all of this up, it is actually about, or slightly less than 500 astronomers, and that's a staggeringly small number of astronomers for a continent with more than 1.4 billion people. If you compare that to the world of astronomy, you have Africa with 500 astronomers roughly, and you have Latin America 3 times more, you have North America with a population of about 350 million people, more than 10,000. Europe has more than 12,000. Asia has more than 7,500. Oceania has more than 1,000 professional astronomers. So that shows that we are lagging way behind the rest of the world in terms of our numbers. On the other hand, we have a very good natural advantage, and that is we have the clearest, darkest skies on Earth. We have minimal light pollution. We have a unique geography for all wavelengths, be it optical, radio, and other wavelengths. And we have a heritage written in the stars, as I tried to show earlier. Now, this is a picture of the Earth taken from space. And this is, I got this from Premium Times magazine from December 2012, depicting Africa as still the darkest continent. And the fact that it is dark in this sense, astronomically speaking, is considered to be a plus, because if we have the clearest skies on Earth, we can do great observations, astronomical observations. So that's why Africa has kind of a superpower in that sense for us, as far as astronomy is concerned. We have this Agenda 2063, Africa's vision for the future. And part of that 50-year strategic framework for inclusive development has actually space science, that includes astronomy in this sense, as one of its 15 flagship projects. And this is supposed to drive innovation, digital transformation, scientific leadership, and so forth. So Africa, at least, the African Union has taken space science as one of its flagship projects, which is a good thing, and that shows there is some kind of a bright future if there is a political will to drive this as well. So I'll briefly talk about the African Astronomical Society, and of course it's a brief history because it is a recent phenomenon. It was launched during this IAU Africa planning meeting in South Africa in 2011. And between the 2011 and between that founding and around 2017 or so, nothing really happened in terms of activities, scientific activities or meetings and so forth. But between 2017 and 2018, it was strengthened by the OAD, the Office of Astronomy for Development. In 2019, AfAS Secretariat was established in Cape Town, hosted by the South African Astronomical Observatory. In 2020, the formal inauguration of AfAS 2.0. The reinvigorated AfAS that was launched in 2011 was kind of reborn as a Pan-African body. And between 2021 and 2023, there were key programs in research, outreach, women in astronomy, and the youth. And last year, AfAS played a key role in hosting Africa's first IAU General Assembly, as most of you, if not all, recall. And from 2025 onward, AfAS has this plan to have a strategic alignment with the African Space Agency that I will briefly mention just now, expand its membership and visibility, and its reach to the rest of the, especially underrepresented parts of the continent. What is the vision of AfAS? The vision is to be the voice of astronomy in Africa and contribute to the advancement of science, technology, and development across the continent. And it has the mission of advancing and supporting astronomical research and education in Africa, promoting public understanding of astronomy's relevance, fostering collaboration among African astronomers and institutions, ensuring astronomy contributes to Africa's development priorities. And it has these strategic priorities of building capacity across the continent, advocating astronomy's role in development, enabling collaboration and policy influence. In terms of its governance structure, it has the executive committee, which includes the president, the vice president, a young astronomer representative, and general members, as well as ex-officio members, which provide strategic oversight of the society, elected by the General Assembly. It approves policies, programs, and the budget. It works with the Secretariat for implementation. And it has a number of subcommittees that report to the EXCO, that include the Science Committee, Outreach and Education Committee, a Women in Astronomy Committee, AFNOA, Membership Committee, Fundraising, Communications, and some special projects like the African Planetarium Association, the African Science Stars Publication, PAX eLab, which is a citizen science-based community, ARAP, and so forth. The Secretariat is hosted by the South African Astronomical Society, and it manages operations, coordination, administration, and so forth. And the General Assembly is the highest decision-making body, composed of all the full and associate members. In terms of its actions and impact, it has the seed research grants for early career researchers. It has outreach projects across Africa, and it runs or supports Pan-African schools such as the PASEA, ASIA, the International School for Young Astronomers, and there's also this PAPSN. And it also runs conferences such as the one that's being organized in Botswana next year, runs workshops and hackathons, and we organize youth networks. In terms of empowering the next generation, it supports school activities in terms of developing school curricula, public engagement and citizen science, women in astronomy, and youth ambassadors as well. Just to briefly mention the Women in Africa program, the AFNOA, African Network of Women in Astronomy, encourages gender equity. It's a gender equity working group and provides mentorship, support, visibility for women astronomers and aspiring astronomers, creates a safe and empowering environment, and it carries out matters of representation and so forth. And the network actually published a book that was launched at the IA General Assembly last year, titled Women in Astronomy in Africa. The IAU-GA was a defining moment for AfAS. It was Africa's first IAU General Assembly in over 100 years of the IAU's existence. There were slightly less than 300 scientists that attended globally, provided global visibility for Africa. There were over 800 individuals from Africa that participated from 28 African countries, showcased African excellence, and left legacies in infrastructure, education, and partnership. In terms of astrotourism, it encourages astronomy, culture, community engagements. Of course, as I mentioned earlier, Africa's dark skies is a superpower, and it attracts tourism as well. astrotourism. It supports Agenda 2063's development goals, as I mentioned earlier, and it also enhances indigenous sky knowledge that adds depth to the astronomical discourse. The big science of astronomy in Africa, you have infrastructure development in the form of MeerKAT, the precursor to the SKA, the Square Kilometer Array, and African Radio Astronomy Network projects. And in terms of capacity building across Africa, we have programs like the National Astrophysics Space Science Program, NASP in South Africa, which is which has nodes at Northwest University, where I am, University of Cape Town, and University of KwaZulu-Natal. It accepts students at the master's, honors and master's levels. And there are plans to potentially also include PhD programs in collaboration with other funding instruments in the future. There is the development in Africa with radio astronomy DARA program, which is a UK-South Africa partnership that has footprints in these other SKA partner countries. And you have also the Pan-African University Institute for Space Sciences that has been in the pipeline for some time now, but it's yet to start. But I think then discussions are still ongoing on this. In terms of global partnerships, AfAS wants to enhance the partnership, create closer partner, work closely with the American Astronomical Society, the European Astronomical Society, the IAU, and also works closely with BRICS Astronomy as well. Wants to explore joint PhD programs, research visits, and exchanges. And also, we want to use AfAS as the voice of astronomy in Africa, as I mentioned. It has an ongoing membership with a UN body, which is Committee on the Peaceful Use of Outer Space. So its voice is increasing on the global stage as well. The African Space Agency that I mentioned earlier, this is part of that Africa Union Space Strategy, which was launched in 2023. Its headquarters were officially inaugurated in Cairo, Egypt this year. And it's mandated to coordinate Earth observations, satellite communications, navigation, and science. And that's where the science part and the African Astronomical Society need to come together. So the Space Agency supports research and integration. So we think we need to have a strategic alignment with the Space Agency, as AfAS. Whereas AfAS does the research, outreach, and education, the Space Agency can support technology, policy, coordination, and so forth. So capacity building, data science, engagement, and so forth are our shared visions for a space fair in Africa. So this is my final part, the call to action. We need to be part of that bright future of African astronomy. One way of doing that is by joining AfAS, be a member. In order for someone to be a member, there are certain criteria, certain categories of membership that astronomers, professional, amateur astronomers, supporters of astronomy can join in one category or another. So this is just to show that there is a platform for people to be engaged in African astronomy by joining as a member, as part of these programs for all kind of individuals in the astronomy landscape. At the moment, membership in AfAS has people from quite a number of countries across the world, as you can see in the map. Blue means we have people whose nationality is from these countries outside of Africa, or those that are nationals of African countries working in Africa that are currently members of AfAS. So we kind of creating a good global reach as well. So the challenge is now to make sure that we have representation from across the world to turn all the map that we see here to blue. And of course, also increase the number of professional astronomers on the continent that will eventually become members of AfAS. I don't think all the professional astronomers in Africa at the moment are members of AfAS, and it's something that we would like to really make sure that they become part of the AfAS fold. In terms of the second action, which is capacity building, for example, briefly mention what astronomy at the Center for Space Research at Northwestern University, where I am, looks like. The NW in South Africa has established an institutional center of excellence that's fully dedicated to space science and astronomy, where there are over 20 permanently appointed astronomers and space scientists, over 15 postdocs on an annual basis, and we have over 50 postgraduate students at the honors, masters, and doctoral studies every year. And research done by members in the science are multi-scale, multi-wavelengths in nature, ranging from astrophysics to astronomy to cosmology. And we also have space physics, a very strong space physics program, and materials modeling for space applications as well. And I managed to also get some information about what Botswanan initiatives in regional astronomy looks like, such as involvement in the MERCAT and HIRAX programs. As I mentioned earlier, also dark skies mean that we could potentially tap into the astrotourism and local knowledge in making sure that astronomy becomes relevant in our community. So Botswana can play a role there, and it's also best positioned for deeper continental involvement as well. And I think BIUST participation in this BMAS collaboration and the PubSim program are also something to be very much encouraged and replicate in other institutes in Botswana and other parts of Africa. And there are many more initiatives and institutions across Africa that are, of course, I don't have the time to also mention. So this is something to be proud of. So the sky is no limit, and I will end by saying that we are small and we're all small under the stars, but capable of greatness. And we have the skies, the minds, and the stories. AfAS is here to amplify your light. And thank you, and let's keep looking up together. This plot here is to show that the trend of astronomy, professional astronomy membership in Africa has been tremendous in the last 25 years or so. So you will see from less than 100 professional astronomers in 2000, we have close to 500 25 years later, and this trend is only to grow faster and faster in the future. Thank you.
Well, thank you very much, Professor Abebe, for an excellent talk. I mean, the historical perspective, and particularly the African historical perspective, was a bonus for me personally. And then you gave a very clear and impressive exposition on AfAS and its mission. And it also emphasized to me the importance of the conference next year, in Kasani. Kasani, I can testify, is a wonderful location, and I'm sure it will be a great conference and a milestone in the development of astronomy in Botswana. It was also great to see so many participants and some old friends among them. I can mention Marcus Butcher and Patricia Whitelock, Don Kurtz, Ian Glass, and several others I noticed here tonight. So that was great. So I'm sure we have time for a few questions, if there are some questions. I don't know whether I can see anybody's hand up. Can I just ask about the funding of AfAS? The funding is from subscriptions and some ministry funding. Is that correct? And possibly some from the IAU. Sorry if I missed this as we went along, but sorry,
you're right that I did not mention that aspect in my presentation. So at the moment, the funding is heavily skewed towards South African government funding. It's funded by the DSTI of South Africa, the Department of Science, Technology and Innovation. We have just recently introduced membership fees that are going to be implemented very soon, but those membership fees are not going to contribute substantially to the AfAS finances. We're introducing them as a way of making sure that members feel committed to the membership and to also assist in small ways to, organize our conference and so forth. The current challenge is that it is heavily South African funded, and the rest of Africa has not played its proportional part, but this is something that we're looking at the moment.
Okay, thank you. Are there any other questions? Well, it's really good to see that the preparations, as we heard in the short talk by Fahmy for the conference, are well underway for next year, and I hope to see many of you there. In the meantime, I'd like to thank Professor Abebe again, and also mention that in 4 weeks' time, the ASB has its next monthly talk. And you'd all be welcome to attend that. I hope that the publicity will be spread far and wide. And again, it's been great to see everybody, so many participants at this talk tonight. There's
there are 2 questions in the chat.
I was just going to look at those. Yeah, I just saw that. Yeah, okay. Okay, so this is from Renier Huff. With all the postgraduate students coming through, what are the plans to keep those researchers working in Africa permanently?
Yeah, Ranier, as you know, South Africa is, especially South Africa, but the rest of Africa as well, is investing in a big way to develop astronomical infrastructure. So I think at the moment we are not saturated enough to have no space for African new African astronomy graduates. And of course, part of AfAS initiative is to also open this networking and making sure that, artificial borders will not limit astronomers' participation in other countries' astronomy projects. So this is something that I think we need to strategically look at and work towards making sure that there will be no brain drain because of our graduates leaving to other greener pastures, so to speak.
Okay. Thank you. There's a question here which says, dark energy is slowing the expansion rate of the universe, which will lead to the big crunch of the universe. I don't know whether that's quite... Anyway, the universe will become a singularity. What do you think of this discovery? What do you think the big bounce model explains our universe accurately. And do you think the big bounce model explains our universe accurately? Explain why not you think it is accurate. I think there might be slight confusion there, but I'll hand that over to I'm glad to hand that question over.
Quite off topic, but sure. The dark energy is actually accelerating the expansion, not slowing it down. And if the current model of dark energy is, the current model of the universe, which is the lambda CDM model, is to be believed, the universe is not going into a big bounce. It is actually going into what we call a thermodynamic heat death, quite the opposite of the big bounce. So the dark energy model is not decelerating the expansion. It is, and it's not definitely going to bring about a big bounce. I hope that explains your question, Man.
Okay. Then we have Kasani is a small town. It's from Don. Where will the conference venue be, and who will be the LOC? So Farmi can answer that, perhaps. You're mute, Farmi, at the moment.
Okay. Can you hear me now?
Yeah.
Perfect. Yeah. So it's a very good question, Donald. So we did go to Kasane about a month or two ago, and it is a small town, as you say, but we've already started discussions with the hospitality partners there. And we've aggregated the rooms that are available. So I think for a conference of 150 people, we'll have more than enough. And we've also preempted them to say the last 2 weeks of March, they should expect bookings for the conference. And in fact, we do have a preferred venue where we're going to be hosting the conference. It's called Cresta Moana Resort and Spa. It's along the Chobe River as well. They have conferencing facilities, and they also have open spaces where if we need to expand the space, we could possibly have a marquee tent there. In terms of the LOC, it's primarily made up of staff here at Boost, and there's an AfAS LOC as well, who we are working closely with. And when we were in Kasane, we got to discuss with the local authorities there, and they also have a local organizing committee for conferences because they host quite a number of conferences themselves. So we'll be working with a team that is based in Kasane, and a number of us here are based in Boost.
Okay.
Yeah.
So thanks, Farmi. I hope that, thanks, Don. That seemed to answer that question as well. And then Aman has got a couple of other questions. Who are the 5 professional astronomers in Botswana and what they specialize in? How can I contact them? And could he have your email address, Professor Abebe? I think the best thing there is for, I think we could send details of the astronomer. We could name the astronomers in Botswana now and go through their specialisms, but I think I'll take a bit of time. So we could if Aman could put up his email address on the chat, we can send an email with all these details to you. I think that's probably the best thing. If Farmi, could you handle that? If Aman will put his email address up and we can send the contact details and so on.
Definitely, Mike. I'll do that. Yeah.
And then there's a science question. What's the difference between a supercluster and a supercluster complex? So I'll hand that one back to Professor Abebe.
I actually don't think I understand what that question is about. Well, you have clusters of galaxies, and all those clusters put together will form a supercluster. I'm not sure what that supercluster complex is referring to.
No.
Yeah, but anybody who knows about those might answer, I guess.
Yeah, I don't know whether anybody else wants to chip in on that one, but I think that's about as much as we can say at the moment. Okay, any other questions? I don't see any hands up, but well, thanks again, Rolf. Thanks to everybody, and I hope that even closer relations between the ASB and AfAS will be developed into the future, and they are actually being developed just because of that conference, but I'm sure that will spin off into lots of other things. And thanks again. It's been a really informative talk, and nice to see everybody. I see that Amon's email is up there, so if Fahmi can send those details in answer to your question, then I think that will be very good. And good evening. Good evening to everybody from a UK which looks slightly warmer than a Southern African one at the moment, which is rather unusual, but there we go.
All right. Thanks, everyone.
Okay. Thanks.
Thank you, Prof. It was very fascinating to listen to you.
Yeah.
Thanks. Bye.
Thank you very much. Thank you. The ASB committee are now going to meet online via a different channel. So thank you. Bye-bye.
Thank you. Bye.